This video provides an introduction to row echelon form of a matrix. In the past, we have solved systems of equations by graphing, substitution, and the elimination method. When solving systems of equations larger than a 3 by 3, using augmented matrices is more effective. One form of augmented matrices we can use to solve systems of equations is called row echelon form. Row echelon form has 4 characteristics. The first characteristic says that any row consisting entirely of zeros, and I'm talking to the left of the vertical line, are at the bottom of the matrix. So if you have a 0 row, it's got to be at the bottom. Characteristic number 2 says for each row that does not consist entirely of zeros, the leftmost non-zero entry is a positive 1, and this is called a leading 1. So I have some examples of augmented matrices below the characteristics here. Characteristic number 1 said that if there was a 0 row, it's got to be at the bottom, and our middle example has that. So if there's a 0 row to the left of our vertical line, it's got to be at the bottom. The second characteristic says that each row that does not have all zeros, the first non-zero entry coming in from the left has to be a positive 1. And you'll see that we have that in all 3 of these examples. And these are called our leading 1s. Characteristic number 3 says for 2 successive non-zero rows, the leading 1 in the higher row, the row above, is farther to the left than the leading 1 in the lower row. And again, we see that happening. I kind of think of it like a stair step down of the leading 1s. So the leading 1 in the row above has to be farther to the left. And then characteristic number 4 says that every column containing a leading 1 has zeros in every position below the leading 1s. And we'll see below all these leading 1s that we have all zeros. And it's only the columns containing leading 1s that have to have zeros below. So let's take a look at these matrices and determine whether they're in row echelon form. This is going to be an important skill for us because I'm going to give you a system of equations. You're going to write it as an augmented matrix and then transform it into row echelon form. We need to know what row echelon form looks like so that we know that we're transforming it to the right thing. So let's take a look at our first matrix. And the best way is just to go through the characteristics and make sure that all 4 of them are met. So characteristic number 1 says that if there's a 0 row, it's at the bottom. Well, this first matrix does not have a 0 row, so that characteristic not applicable. Characteristic number 2 says for each row that isn't all zeros, the first non-zero entry coming in from the left should be a positive 1. So here are our first non-zero entries coming in from the left. Are they all positive 1s? No, they are not. So since that second characteristic is not met, this is not in row echelon form. And I'm going to stop right there. There's no reason to check the other characteristics because all characteristics have to be met. Let's move on to our next one. Characteristic number 1 says if there's an all 0 row, it's at the bottom. We don't have one. Characteristic number 2 says the first non-zero entry coming in from the left is a positive 1. Is that the case? Yes, it is. Characteristic number 3 says that the leading 1 in the row above has to be farther to the left. And we see that the leading 1 in the row above is always farther to the left. And then our last characteristic to check is below each leading 1, it needs to be all zeros. So if we look below our leading 1s, is it all zeros? Yes, it is. So this is in row echelon form. Last example. If there's a 0 row, it's at the bottom. That's characteristic number 1. Well, here we do have a 0 row, and it is at the bottom. So that first characteristic is met. Characteristic number 2 says in each row that's not all zeros, the first non-zero entry coming in from the left is a positive 1. Is that the case? Yes, it is. Characteristic number 3 says that the leading 1 in the row above has to be farther to the left. Also true. And then lastly, below each leading 1, it has to be all zeros. Characteristic number 4 is also met. This matrix is in row echelon form. Now that we know what row echelon form looks like, let's see how we finish a problem once we've gotten our matrix into row echelon form. So let's consider the matrix there. The first thing we're going to do is rewrite it as a system of equations. I'm going to use the variables x, y, and z. We'll have 3 equations. The first one, 1x plus 1y, there's no z's, is equal to -3. In our next equation, notice there's no x term, but we have 1y plus 1z is equal to 1. And in our third equation, there's not an x or a y term, only a z. We get z is equal to 2. Notice that when we rewrote our system of equations, one of the variables is solved for us. We're going to use the fact that z is equal to 2, and we are going to back substitute it into another equation to solve for a different variable. So since z is equal to 2, I'm going to plug that 2 into the equation y plus z equals 1 and solve for y. So that gives us y plus 2 is equal to 1, making y equal to -1. Now we've solved for a second variable. The last variable that needs to be solved for is x. It's in the equation x plus y is equal to -3. So this time I'm going to take -1 and I'm going to plug it into that equation for y. We get x plus -1 is equal to -3. So that's x minus 1 equals -3, making x equal to -2. Since we are solving systems of equations, be sure once you get your solution that you write it as an ordered triple. We would get the solution -2, -1, 2. Now that we know what row echelon form looks like and how to find the answer once we're in that form, we need to learn how to get our original augmented matrix into this row echelon form. There are only 3 legal row operations that we can perform on an augmented matrix. The first legal row operation is to simply interchange 2 rows. And I'm going to tie these row operations to what we do when we're solving systems of equations using the addition method so you can see where they're coming from. So say we were solving the system 2x plus 3y equals 6, 5x minus 9y equals 2. If I wanted to, for whatever reason, I could flip-flop the order and I could put the second equation on top and the first equation on bottom and then solve using the addition method that way. So that's just what our first row operation says, that you can simply interchange 2 rows since each row represents an equation in our system of equations. When interchanging 2 rows, you're going to use the notation R1 interchanged with R2. Once we start solving systems of equations using row echelon form, it's going to be really important that we write down the row operation for each step. So this one, row 1, interchanged with row 2. Our second legal row operation is to multiply a row by a non-zero constant. So maybe we were solving a system of equations like y plus x equals 27, and then our second equation had a whole bunch of decimals in it. I certainly don't want to solve a system of equations containing decimals, so the first thing I would have done is I would have multiplied this second equation by 100, because that would then clear the decimals for us and leave us with x plus y equals 27 and 5x plus 10y equals 265. This move here is what this second row operation is talking about. And to label this move properly, I multiplied the second row by 100 to get a new second row. So we would write that 100 times row 2 for a new row 2. These first two row operations are the ones that we use most of the time. Right. These first two row operations we're going to use to create leading ones. Our third row operation, well, this is the one we use to create zeros. And those are the zeros below the leading ones. This third row operation says that we are going to multiply a row by a non-zero constant, add it to another row, and replace that other row with the sum. So let's go back to solving systems by the addition method. Say I had 2x minus 3y equals 8, and 5x minus 6y equals negative 4. If I was using the addition method, adding down, no variable falls out. So what we do is we multiply one of the equations by a number, so that the coefficients on one of the variables are opposites. That gives us a negative 4x plus 6y equals negative 16, and 5x minus 6y equals negative 4. We would then add down, the y's fall out, leaving us with x is equal to negative 20. Well, that right there is our third row operation. We multiplied one of the rows by a non-zero constant. We multiplied by negative 2. Then we added it to another row. And then we'll have this new row to replace it with. Writing down this row operation, this would be negative 2 times row 1 plus row 2 for a new row 2.